This is the second part of my videos to show how to create uncensorable content using IPFS and the Bitcoin blockchain. In the last video, I showed how to create a blog using Gatsby and Markdown, and also just talked about the reason why I'm creating these videos and the significance of it. And these videos are meant to be high level, and so I go over quick and I don't really go very deep into some of these technologies. They're intended really to point you in the right direction and give you the clarity you need to self-educate. So that's why I'm not going into a lot of depth. This one's going to get a little more technical, and it's going to wrap up the video, and then depending on how these videos are received, I may make a third video showing you how to do everything I'm about to show you in this video anonymously using Bitcoin Cash and Tor to anonymize yourself. So, with that little teaser, let's jump on in here. So this is the second video, and we're going to be covering uploading your website to IPFS. So let's go to the Gatsby starter, and I'm going to go run it in development mode so I can show you a couple changes I made since the last video. There we go. So I changed the home page a little bit. I added some links to the first video I made and to the Honest Cash post. So let me just show you what this is. This is the Honest Cash. This is Memo.cash. I'm sorry, Honest.cash is something else that's definitely worth checking into. But Memo.cash is a social media site very similar to Twitter, and the main difference, it's a little rougher around the edges. So for instance, this is the tweet or the post I made this morning of the first video, and I have a link here to the IPFS gateway where you can download it. I have the IPFS hash if anybody wants to download it directly. I also uploaded it to YouTube. The main difference between Memo.cash and Twitter is that Memo.cash runs on top of the Bitcoin Cash blockchain, and so all these tweets or posts are op return commands in a Bitcoin Cash transaction, and because they're combined with all the financial transactions on the Bitcoin Cash blockchain, they are incredibly difficult to censor because everybody with a financial interest in using this cryptocurrency is going to syndicate this content, and that can be a double-edged sword, but that's the reality that we're in right now. So let's take advantage of it to create censorship-proof content. And so that's what Memo.cash is capitalized on, and this is how we're going to syndicate our content after we upload it to IPFS. And so let's talk about that a little bit more. But I was showing you the changes I made to the blog. So I just added a bunch of links. That's what these are. This is the direct hash to download directly off of IPFS if your browser's set up. I have this little IPFS browser companion, and if I turn this on and I click this link, it would just go out and fetch it from the IPFS network. For people who don't have the browser extension or don't know what IPFS is or how to use it, this link will go to the IPFS gateway. There's also a Cloudflare gateway, and they'll be able to download the content from there, or in this case, view this website. And although these are links to the video I made, not this website. So anyways, these are the changes I made, and these are the topics I'm going to cover in this video. I'm going to talk about real quickly about the difference between the server and client model, which is how the regular internet runs, and then I'm going to talk about the IPFS model and how it's different graphically. Then I'm going to set up a server, a cloud server. DigitalOcean is a company that I like, but you could use Amazon or Google or Microsoft Azure. There's also Vultr and Linode. Those are a couple good companies I like. I just prefer DigitalOcean, so that's who I'm going to use. And their cloud computers are called droplets. Amazon calls them EC2. Everybody's got a funny little name for them. They're just computers in the cloud. And then I'm going to walk through the example of uploading the website to IPFS and then syndicating it over the Bitcoin Cash blockchain using Memo.cash. And then I'll discuss some gotchas and sort of where I think the future is going, where this technology is going in the future. So yeah, that's talking about syndication. That's the example. So first, let's talk about the client-server model. This is the conventional web. This is you over here. You're a client. You run a website, or a web browser, and you have an IP address, and you connect through your ISP to a website, which is a server that serves those websites, and it has an IP address. And the internet works on IP addresses. So, whatever.com or google.com, those human readable names, that's not how the computers work. What your computer does is it goes out to a service called DNS, the Domain Name System, and it says, hey, I want google.com, and the DNS says, okay, here's the IP address for google.com. So then you reach out directly to their computers. And this is how the internet works. This is how the web works. So if someone wants to censor content, there's two ways to do it. They can sever the connection to the server, which is like a 404 error, or just when content gets lost. That's the experience there, but that's also how it can be censored. Or you can cut the connection to the DNS server. If you've heard of like different governments taking over domain names, that's how they're doing it. They've got some legal power in the last 10 years that they managed to summon, and a few countries have actually been successful in wrestling domain names away. And so that's another very clear attack vector that is being exercised commonly these days. So in contrast to this model, this is the IPFS model. So this is us. Again, this is the computer I'm on right now. I just created a web page. What I'm going to do is I'm going to create a cloud computer, and I'm going to upload it to that cloud computer. And that way I can open and shut my laptop, and I can go on and off the network. And my server's just going to stay there and serve that content. And this server, this can be anything. This can be, in this example, I'm going to use a DigitalOcean droplet, just a cloud computer. Like I said, there's lots of cloud computing companies. You can use a Raspberry Pi. You can use anything. Basically, what makes a good syndication server is anything that's directly connected to the internet that's not firewalled. Like a home computer, when you walk around and connect to a Wi-Fi signal, you're behind a firewall. And so that can still work, but it won't work as well as a computer that doesn't have any firewall. And a cloud computer typically won't have a firewall, or at least DigitalOcean droplets don't by default, which is one of the reasons I use them. So anyways, when these are both uploaded, they'll both be able to serve content to the general internet. And then anybody who downloads the content will also share the content to the general internet. And that's where it's kind of like BitTorrent in that way. Like anybody who downloads the content will also seed the content for a little while. And but the main thing here that I want to get through is that everybody involved is sending and receiving content, and so that improves the situation immensely. So the more people who actually download the content is better, because that means there's more people syndicating the content. But usually you just start out with one computer, and then it's a good idea to get some sort of cloud computer or just a Raspberry Pi connected to the internet with a hole poked through your firewall if you know how to do that. So it doesn't have to be expensive, but it just works better. So I'm just going to show DigitalOcean Droplet because that's pretty convenient. Okay, so we talked about the different models, and I'm going to show you this is DigitalOcean. This is what it looks like after you create an account. And I created right here these droplets. I created a droplet for this example, and it's already fired up and running. And I'm going to show you how I did that. I went to Create Droplet, and I'm doing an Ubuntu server. I think all these are pretty much Linux, but this is the most common. And usually I'll actually bump this up to 1804. That's actually the best one to use. And then I'm just going with the cheapest package, which is $5 a month. And San Francisco's fine. And then you would give it a name, whatever. And then you hit create, and that would create your droplet. And that's how I created this one. And then it emailed me the IP address and the password for the root login. And so I already did that. I already logged in to right here. You can see it says root and IPFS test, and that matches the name here, IPFS test. So I'm logged into my cloud computer here, and this is what's going to stay up and serve my content so that I can close my laptop at night, and my content's still going to get served up to the network. And so let's do that. So if I go back to the right here, so this is, I built this. So I showed in the previous video how you can go npm run develop to do a live view, and that's what I just did to show you the examples the changes I made. You can also go npm run build, and that will build and populate this public folder with all the content, and then you to add it to, or to hash it, to add it to the IPFS network, you need to install IPFS. And the place to do that is IPFS.io. And we're going to need to install it both locally on your local computer and on the server. And so we're going to do that. If you go to try it and then install IPFS, you'll get a link here to download. And right here is the Go IPFS GX. We want the latest Go IPFS, and that's going to give you a tar file. But I've already installed it on my computer, so I'm actually going to copy the link, and I'm going to go to the cloud computer, and I'm going to issue a wget command, which downloads web content. So there's the file right there. It's a tar file, so I'm going to unzip it. And then I can run this install script. And I probably need to go, oh, I'm root. That's a nice thing. Okay, IPFS is installed. And so what we need to do is start the daemon. Oh, actually we need to initialize IPFS. And I'm going really fast, but to learn more, you want to go to docs.ipfs.io and read through all this really great content here. They've got some really great getting started guides, and the basic usage one's pretty cool. They've got some really great basic examples talking about all like cool little things you can do with IPFS. Okay, so we initialized IPFS. We got our ID. We can run the daemon and just make sure that this is going to run. Okay, it looks like it's running and everything's ready. So now that it's running, I'm going to send it into the background. So I hit Control-C to cancel out of that, and then I'm going to go no-hup IPFS daemon, with the ampersand. And what that does is it's the same command I just ran, IPFS daemon, but the ampersand sends it to the background, so it's not taking up the screen, and then it's writing the output to this file, nohup.out. So if I cat that, which is cat is print to the screen. That's everything I just got. So the daemon's up and running, and if I do PS, I can see it running right there, process 1842 IPFS, so that's running. So okay, so now the server, what I just did is this here. This is set up now, and I can go IPFS ID, and I can see my ID, and what I want to do next is connect my local IPFS. So this is the daemon running on my local computer, and if I go IPFS swarm peers, I can see all the peers I'm connected to. I want to go IPFS swarm connect, and let's just see if we can find each other through the network. And then if this doesn't work, I can try and pull it up directly by its IP address. But this is part of the IPFS networking layer. And this is pretty intimidating to walk through. Like I said, this is not really intended to be a how-to. It's more of a really quick run-through to give you the commands to Google and the way to sort of self-educate. Okay, that's not coming up, so I am going to do IPFS swarm connect. I'm going to use the IP4 address. If I go over here, I can do if config and get my IP address of my cloud server right there. And I'm just following this pattern. That's probably 4001 because they're all 4001. IPFS. And then this was the IPFS ID of the cloud server. No protocol. Did I swap them? Oh, TCP. So it's the IP address, and then we're connecting over TCP on port 4001. There we are. Now we're connected. Okay, so what I just did is I connected the IPFS node on this laptop that's recording this video to this cloud server running in the DigitalOcean cloud. And so now they're connected over IPFS, and now I've already run that npm run build command right here, and I populated that public directory, and now I can go npm run add r for recursive public, and that's going to hash, IPFS add r public. That's going to hash the directory, and this last one, this very last hash is the one you want. That's for the directory. So now that you've done that, you can go back over to your cloud server and go IPFS get, and then paste the hash of that public directory here. And so now it's trying to handshake between the cloud server. This is like, the new FTP, right? And let's see, if I go IPFS swarm peers and then grep QSGP, that's the last 4 digits of the hash. Okay, there, I can see I am connected. Okay, it just took it a minute. So my laptop's currently uploading it. Almost done. Come on. There we go. Okay, and then you can see this directory, this QM blah 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 directory. So now the cloud server has the directory, and I'm going to run one more command, IPFS pin add, and then that hash again. This prevents IPFS. If you're not using content, it'll do what's called garbage collection and get rid of content that you're not using. And so by pinning it, you're telling IPFS hey, don't throw this away. I want you to keep this and syndicate this. That also means syndicate this out to the network. So that's it. Anybody who requests this content can get it either from our cloud computer or our laptop when the laptop's online, assuming that IPFS can sort of negotiate this network route to get to the content. And okay, so now that that's there, anybody can retrieve it. You can share out this content. But what's also cool about it is there's these gateways. And so this is where things can kind of get a little wonky. There's this cloudflare-ipfs.com gateway, and there's this gateway.ipfs.io. I'm going to open up both. These are links for Wikipedia. They actually have Wikipedia, the whole thing, uploaded to IPFS, and you can retrieve it over IPFS. So for some reason, and the reason they do this is because governments are fond of banning Wikipedia. The U.S. government hasn't done it yet that I'm aware of, but the governments of Turkey and I know has banned it several times, and I think Iraq. I'm sorry if I'm incorrect about that, but there are countries that have banned Wikipedia, and so if Wikipedia is banned in your country, you can retrieve it over IPFS. It's very handy that way. The only trick is getting this weird hash and knowing how to do that. So we're going to show you how to do that, because chances are someone is running a Bitcoin Cash full node in your country, and if they aren't, they should. And if they are, they have the blockchain. And if they have the blockchain, you can send a transaction with your hash on the blockchain and easily retrieve it with memo.cache. And that's what we're going to do right now. So first of all, let's see if we can pull up this hash. So we pinned it. And this is effectively our website. It's a really ugly URL. And some of the stuff I'm going to cover in the gotchas are becoming evident. This is where the user experience really starts to break down. And usually this can take a while. Sometimes you just at this point you just need to walk away for a half hour and let your cloud server just sort of simmer. And what it's going to do is it's going to go out and connect to the network. Not that one. IPFS swarm peers, I think is the command. Yeah. So these are all the other IPFS nodes that the cloud server is connected to, and it just made these connections. It's constantly going out and finding new nodes to connect to. Man, that's a big list. And that's why using DigitalOcean is pretty sweet, because it's in a big major data center, and so it finds new computers really fast, and it syndicates data really fast. And I was hoping that we might have half a chance of making this gateway thing work. But, yeah, that's a bummer. What I can do is I can turn on my little plugin here, and that's actually running an IPFS node directly in my browser. And it's smart enough to know that, hey, why get it from the gateway when I can just get it from myself? And of course, this live demo is not working. Okay. Well, this is a bummer. But conceptually, this is how it should work. Let's see if we can just pull it up directly. Yeah. I'm not sure. Let's check. Make sure we got the right hash. EDV. Public. You know what? I'm just going to go npm run build. Let's try this over again. Okay, we built it. IPFS, add our public. We're going to hash it. Oh, look, the hash changed, so that means there's something different about the file. So now let's try and just load this locally before we upload it to the server. There we go. Yay, hooray, that's what it's supposed to look like. Okay, so now we got the right hash. And, shoot, what was that ps command, or that grep? Let's see. Here is our cloud server. And we're going to go IPFS set ID. Right now I'm just checking to make sure that I am connected to the network. IPFS swarm peers. Oh, yeah, that's it right there. We're not connected. So we're going to reconnect. Make sure we're connected. Okay. And now we'll get this. And I'm going to delete this old one. And I'm going to get the new one. And I'm going to do IPFS pin add that hash and pin that. Okay. So now that we have the right stuff uploaded, we can try well, we know we can get it locally because we just did that. So I'm going to turn this guy back off. And we're going to give these gateways another go. I don't know, for some reason one wants to come up in Firefox and one wants to come up in Chrome. I don't understand it. But now that we know we're dealing with the right content, okay, there we go. It's resolving. And bam, man, that's awesome. Okay, so this is the gateway IPFS, and that's usually a little faster than Cloudflare. Cool. So here's all this. Okay, so now that we're here, I'll just bring up Memo, and I'm already logged into Memo. So it's important to really understand Memo. It's important, like memo.cache is a website, like twitter.com is a website. The data on Twitter is proprietary data that Twitter owns and guards and protects and covets, and it's data that they harvested from you. And Memo is just reading the Bitcoin Cash blockchain. It doesn't have any of its own data, or has very little of its own data. Not the content. The content is actually coming directly off the Bitcoin Cash blockchain. So let's see if I go to posts and Naomi Brockwell. If you're not following her, I suggest you do. She was one of the first people to cover Julian Assange's arrest. So props to you, Naomi. Okay, I'm going to do a new post. I'm going to say, check out my example blog built with Gatsby and syndicated over IPFS. And what I'm going to do is grab these gateway links. And this way, anybody in a regular browser can, well, I'll just do another one. So because this writes directly to the blockchain, that means you have to have Bitcoin Cash. So this is in Satoshis. So this is what's that worth? It's definitely less than $20. It's probably less than $5. And posting a memo is like, I don't even know what the cost is, but because I've never bothered to look, it's so small. I don't know if it's a fraction of a cent or a cent, but when it's that cheap, who cares, right? And so bam, that just went to other links. And then, of course, I can do IPFS : / and then the hash. That works as well. Cool, I can fit that all in one post. So you can do as many as you want. So this was a transaction, and this was a transaction. And in fact, I think it's the transaction IDs right there. So you can actually go to the Bitcoin blockchain and put the transaction ID in here, and you can see there's the op return with the data, and I believe they decode it right here. They detect that it's a memo transaction, and here is my tweet right here with the link. So the retrieval hash, as long as any one computer, I mean definitely the server, this cloud computer we just set up is going to be online because that's what we're paying for. But if any computer connected to the IPFS network has this file, has this directory, it will serve it to the network, and this content will never die. And but it could still. So there's this whole. So that this brings us, now that I've kind of showed you the process. Let's talk about gotchas. I didn't really go through here, but this was the 3-step process. We needed an internet-connected node, which we installed IPFS on our cloud computer. That got us to step 1. Step 2, we uploaded our file to the server using IPFS. And then step 3 was we just posted the retrieval hash to the blockchain using a memo post. And yeah, I guess that's so. Obviously, there's some gotchas, and one of the gotchas is this whole user experience sucks, and it could be made way better. And what I showed you in terms of creating the website and building the website, that's pretty normal. That's par for the course for a developer. That might have looked really. This whole thing probably looked crazy if you're not a technical person, but that part's pretty normal. The whole working with the IPFS stuff on the command line, that's new. That makes a lot of people uncomfortable, so that needs to be improved. Even if that was improved, this whole process of retrieving data from these gateways sucks. And here's the gateway. And it takes time. This was actually pretty snappy, and I think it had everything to do with the fact that I was using a cloud service, but that's a centralized service, so it kind of defeats the point. So this is a great start. It's decentralized. In theory, it should be hard to take down. In practice, it's really not that hard to take down. It's also pretty damn hard to find, because now I've just restricted myself to people on Memo. I could put these links anywhere. I could put them on Twitter. I could put them on any social media. So it depends on how deep down the rabbit hole you want to get in terms of like security and how badly you're going to get censored. I'm just some guy, so not a whole lot of censorship to worry about. But if we're thinking about somebody like Chelsea Manning, well, they need to be able to do this process, and they need to be able to be anonymous. And so I might make another video showing you how to do that, how to use Tor and Cash Shuffle and Bitcoin Cash to do everything I just showed you in this video and do it anonymously and not leave any trace. But this is going to improve. IPFS is here to stay. The company behind it has a lot of money, and they're in it for the long haul. They're dedicated to this computer. They've got a path to monetization, so they have good money to work from for years, and they have a clear path to profit. And so I'm very excited about this technology and its staying power and its open source roots. A lot of respect for Juan Bennett and David Diaz and all the people at Protocol Labs. And I think this is the future, and I think writing this retrieval hash to the blockchain is also the future. This whole user experience could be streamlined, but the point is the technology's here now, and it exists, and it can be used to syndicate unstoppable data, particularly if people work together. If piece of content is particularly hot, this phenomenon is called the Streisand Effect, when the government or some entity in power tries to suppress information, and it actually causes more attention to be given to that information that they're trying to suppress. That's called the Streisand Effect. It goes back to Barbara Streisand. She was the first person to try this and it's a new internet phenomenon. It's only existed as long as the internet, because the internet's all about sharing information. Information wants to be free, and it has evolved, and I think this is the next stage in its evolution, is syndicating information through IPFS in a way that is extremely hard to censor, because it magnifies the Streisand effect. The more people who download the content, share the content, that makes the content easier to distribute and much harder to censor. And so that's the power of this technology. And this phenomenon is solidified in IPFS and the Bitcoin blockchain. We have two independent. There's other. There's Ethereum and stuff too, but these two blockchains, or IPFS isn't really a blockchain, but it kind of is. But anyways, these two technologies are centered around this phenomenon of being widely distributed, so much so as to be ubiquitous, and that's where it derives this sort of unstoppable power from, and it's the future, and now you can do it. So I hope that you practice this and post it, and let me know if you like this video, and if you do, maybe I'll do this third video showing how to do this anonymously.